so the purpose of adding that sodium hydroxide was to get it neutral, and then when you did that, or have it maybe slightly acidic, so at this point, if we were to look in our bucket, what we had in our bucket at this time, we had hydrogen ions from our acid, we had hydroxide ions from the base, we had sodium ions from the sodium hydroxide, we had excess nitrate ions left over from the acid, and this was our money maker right here. This is what we wanted. This was the blue stuff, the copper 2 nitrate. That's our money maker. That's what we want. Now, if you added too much sodium hydroxide, this is what happened. You got that greenish, bluish, different color kind of thing. And if you look up a picture of copper 2 hydroxide, it's like a pale blue. Copper 2 nitrate is a darker blue. Okay, and if you got that different color blue that kind of gave it that greenish tint to it, this is what happened here. You got this reaction happening, and you didn't really want this reaction happening. Because you added excess acid back to it? Okay. All right. Yeah, if you had, like, tell me what happened. Tell me what you did. Okay.
I think that's the step where we added more, where we had to add more, it wouldn't work.
No, that was the pH.
pH.
That's all we kept adding.
Okay, well that's all.
Okay. At any rate, but this is one possible source of error right here, because your lab is going to include error analysis. So it's important that you discuss this in your lab, saying that if too much hydroxide was added, then you had this side reaction going on that you didn't want. This was not the point of our lab. But if you added too much, that copper 2 nitrate combined with the sodium hydroxide, or reacted with the sodium hydroxide, and you got copper 2 hydroxide precipitate, and then you'd also have some sodium nitrate aqueous in the solution. Okay, but that right here was that color that you did not want. Okay, so that is that side reaction. If you had excess hydroxide, is one source of error that you could have had that could have affected something. Okay.
What's that lead? Was it 2E and what?
Sodium nitrate. I just rewrote it. Okay. Now, this is a systemic type of error. Systemic type of errors. Human includes human error, things that your technique. Okay, and we all have that. Now we're still on part B, but the next thing you did was you added the sodium phosphate. Okay, so this was your second reaction that you wrote down, I think. Or was written down for you. All right. But you had copper 2 nitrate. You added your sodium phosphate to it. And you had copper 2 phosphate that was inside of your filter. This is what you filtered off, and then you also had some clear sodium nitrate solution floating around. Are y'all with me or not, or, okay? But you see what I'm doing, right? I'm looking at my reactions. I'm looking at what I have, and I'm just, yeah. So I had, when I add that sodium phosphate to it, I had a reaction going on, and I ended up with copper 2-phosphate solid in my filter, and I ended up with that clear sodium nitrate down here as my filtrate that I threw away.
That's where you lost some.
Yeah, if you ended up with blue stuff in here, if this was blue at all, your filter paper may not have been seated in there correctly, and this could have been a big source of error here where you lost some of your copper. Okay. Then the next part, you added hydrochloric acid to it. And when you did that, that hydrochloric acid reacted with that copper 2-phosphate, and you ended up with copper 2 chloride down here. So now your bucket contains this blue copper 2 chloride, and it also has some leftover, stuff in there from this reaction. It could have some phosphoric acid in here, but I know you can't read that, but what you did, you took copper 2 phosphate, you added hydrochloric acid, and you got copper 2 chloride and some phosphoric acid. Okay? Now it's balanced up here, it's not balanced down here. But in here, this copper 2 chloride is aqueous, and that is your blue stuff. And then you also have some acidic, some phosphoric acid hanging around in there. Does that make sense? Okay. Part D. You added your magnesium, and you saw bubbles, and then you saw that it turned brown, and you ended up with this brown stuff at the bottom, which is your copper, and this right here was clear. Well, you had a single replacement reaction happening here. This blue stuff was your copper 2 chloride that was aqueous. You added your solid magnesium to it. The magnesium kicked the copper out of the way. And you got magnesium chloride, which is a clear aqueous solution. That's this clear stuff here, plus solid copper, which collected down here. Okay, this was also a redox equation. And this is a simple redox equation because all it did, the magnesium went from a 0 to a +2 charge, so it lost 2 electrons. Your copper went from a +2 to a 0 charge. It gained those 2 electrons. And then you decanted the liquid, and I don't think this class, I think we let it dry. I'm not sure, but some people did actually have to use the acetone to dry it. The only reason for the acetone was to help it dry quickly. Okay, so then after you get done, I want you to answer those post-lab questions. So I know that it is not, I know it's work, but we've put in a week's worth of work in here, and I want it to be reflected that you understand it. You know what I mean? Okay. Have a good day.